So first off, thanks for being here and taking your time to come and pay attention to this. And so the short story, we'll get into the details, but the short story is, looking at mental influence. Does our intention influence things in the physical world? And is there a way to shift the way the brain behaves that can influence this? And so that was kind of the idea behind this little pilot study. And I say pilot study because, it was really a smaller group of participants than we would probably like to do in a larger study. But it was really, trying to kind of like get an idea. Let's study this and get some ideas about how this works or what we can learn from this to move forward. So I'm going to go ahead and share my slide deck. This was originally presented at the International Society for Neurofeedback and Research Conference last year. I was actually a little surprised that they accepted it. It's a little kind of woo-woo for them, but it was interesting. I had really good attendance to the talk and a lot of interest. So I thought that boded well, if that's the right way to say that there was enough interest that they would actually let me talk about this in that kind of a conference. There we go. Okay, so I'm just going to dive right in. So what are we talking about? So this whole thing is really about this idea of psychokinesis. And, sometimes you'll hear this referred to as telekinesis. I think the preferred term now is psychokinesis. But really what we're talking about is the ability to manipulate things in the physical world with your mind. So being able to alter something. And so, a lot of times when people are practicing this, it's things like, in fact, some of the original research with psychokinesis used rolling dice, right? So you're rolling dice and there's a 1 in 6 chance that a particular number is going to come up. And so asking people, can you influence this so that more ones come up or more sixes come up or whatever it is, and have them roll the dice a bazillion times and see if they can get an outcome that's supportive of their intention, right? So that was the early research. There's other ways that we think of, we think of spoon bending, and we think of, moving a ping pong ball on your table with your mind, or moving a pinwheel, which is what this little picture with the bowl, the glass bowl. This is actually a fun way to practice. Have just like a needle with something suspended on it, like a piece of paper, and then, using your mental intention, see if you can move that piece of paper, where there's no wind or air that's able to influence it. So these are the kind of things we think of with psychokinesis. However, these things are a little bit hard to study in the lab, this kind of stuff. And so we're going to be talking about a little bit of a different branch of psychokinesis. We're going to be talking about something called micro-psychokinesis. So all that other stuff that we talked about is considered macro. It's bigger. It's stuff you can see with your eyeballs, something that gets influenced. Micro-psychokinesis is really looking at really, really small events and things that typically you can't see with your eyes, things that are happening in the background that you can only see through statistical analyses, that there's an influence. And so the way this is usually studied is by using something called a random event generator or a random number generator. It's the same thing. And basically what this is, it's a program that's spitting out ones and zeros in the background. And they have ways to make these truly random, right? Through quantum processes that is way beyond my pay grade to understand the technicalities of it. But that's different than having an algorithm that spits out random numbers, because it's still an algorithm, right? So it's not truly random. But all the programs that we use and that most of the research in this area uses are truly random. So what's happening is the program is spitting out ones and zeros in the background. And because it's a computer program, it can spit out hundreds or thousands of these every second. And so what we know, right, is that if you have two options, so you're like flipping a coin. If you flip a coin 1,000 times, you're going to get pretty close to 50% heads and 50% tails, right? Because there's two options. And the more times you do it, the closer it's going to get to 50%. And so, you might end up with 498 and 502, but it's pretty much 50-50. And so that's what we're doing with these programs is we're spitting out numbers and saying, well, half the time it's going to be ones, half the time it's going to be zeros. So then the idea is to have somebody tune into this and ask them, can you make more ones? Can you make more zeros? And so then we can statistically analyze that and say, well, is the response that we're getting more than what we would expect by chance, right? So the implication is that there's some form of interaction between consciousness, between our minds, and the physical world, right? That we can override normal mechanisms. So the normal mechanism in this case would be 50%. Can we override that? Now, this has been studied for decades, right? And in fact, probably the most famous set of experiments was conducted by the PEAR Lab. So this is the Princeton Engineering Anomalies Research Lab. And guess what? It was at Princeton. And so, this is really, really cool. And it was in existence for quite a long time. You can see from 1979 to 2007, they had a lab that this is the kind of stuff they studied. And so there's, dozens, maybe hundreds of papers out there looking at this type of influence. And so this is just one example, right, of some of their data that they collected over a number of years. So over 12 years with 91 different volunteers, they had 2.5 million trials. And what a trial is, right, is going to be that there's going to be an instance where the person is saying, okay, I want more ones. And then the screen displays in some way if it was a 1 or a 0, right, that showed up. And so that's one trial. So we're talking 2.5 million trials. And what they would do at the PEAR Labs, the typical experiment, is the random number generator, instead of doing ones and zeros, they would have random numbers between 0 and 200. And so, of course, when you do enough of these, the average is going to be 100, right, if you average all those numbers. And so it's kind of the same idea, but they would have people come into the lab and say, okay, I want you to make high numbers, make more high numbers, or make more low numbers, or make numbers in the middle, right? See if you can do that. And so this is a chart that they provided that shows the results of all of this data. So basically what you're seeing is down the middle, this hard line down the middle, that's basically 50%, right? That's exactly where you'd expect things to wind up, is down the middle, if everything was 50-50. So when they asked people to focus on the higher numbers, this top line was the result. So you can see how far away from average it is. And this was statistically significant at 0.0004 level. And so if you're familiar with statistics, that's extremely significant, right? Usually anything that's 0.05 or smaller is considered statistically significant, meaning there's very little chance that occurred just randomly. Now, here's what happened when they asked them to focus on the low numbers. They got this bottom line, which was significant at the 0.022 level. And in this line, this is kind of interesting. This is the one where they said, focus on the middle ones. And it's actually kind of drifting up, right? Which is kind of interesting. And that'll come up later when we think about some of these things, because we see certain responses that tend to show up over time that are fairly consistent. And actually, you can see one of them here, which is that people tend to do better with high numbers. Or if you're doing ones and zeros, they do better if they're focusing on ones than zeros. And so it's interesting, right, that this one, the high values, was more significant than the low values, and that even the neutral numbers had an upward trend. I don't know if it's that we associate high numbers with being better or something. I'm not sure what it is, but that's just an effect that we see. So the point of showing this is just to show that there's been a lot of data done with this, and it's pretty convincing, right, from a statistical perspective. And in fact, there's been a number of meta-analyses conducted over the years looking at all this research. And a meta-analysis is really a research process where you take a bunch of studies that were done basically the same way, and you pull them all together. And you say, well, what was the overall findings, right, from all of these different studies? And so there have been a number of these done, and all of them were statistically significant for the micro-PK effect. So that's all of these first 4. So again, here's 50%, this hard line, and you can see that these meta-analyses were all significantly above that. This last one was a control study where they didn't have anybody paying attention to it, right? They just ran the random number generator a bazillion times. And that one was actually just slightly below 50%, which is, more in line with what we would expect. Now, an important piece of this, there's a couple of important pieces. So one, Dean Radin, who many of you are going to be familiar with, he's the chief science officer at IONS, the Institute of Noetic Sciences, and does a lot of this kind of research. And he's actually written a couple of these meta-analyses. And so he calculated that when you look at all of this, the odds against chance were 30 billion to 1. So again, the idea that this is not real, it just doesn't stand up. So this is considered proof-oriented research. Can we demonstrate that this is happening? And the answer seems to be yes. Now, the other important part of this is that the effect is very small, right? So if you look at the reality of where they were scoring, here's 50%. This one, which is the best one, it's 50.016%. So is it above 50%? Yes. Is it statistically significant? Yes. But the real world effect is pretty darn small, right? It's like barely above chance. And so this is interesting, right? Because clearly there's something happening, but it's very, very small. The effect, it's not moving doors, right? It's like a very tiny, tiny effect. And so one question, of course, is, well, why aren't these results more impressive, right? What we'd like to see is, Yoda lifting an X-Wing fighter out of the Dagobah swamp, right? That's what we would like to see. But we see these teeny tiny effects. And there's a couple of reasons why this may be the case. So one of them is something called directional trends. And I've seen this a lot, actually, in some of the research I've done with this work, which is that somebody might be intending for more ones, but what happens is there's more zeros. So it goes in the opposite direction. It's still significant. It's still statistically significant. It shouldn't go that far askew, but it does, right? So this is a problem, because if you're saying everybody needs to move it up into the ones, but then somebody's getting all these zeros going straight down, it's going to mess up the data, right? So this happens. It's a thing that happens. There's also something that we see called the decline and recover effects, which is that people often do better at the beginning and at the end of their trials. So, the middle tends to kind of like flag out. So again, you're kind of like losing some of the effects, right? Because it's like, oh, this is looking really good, but then it kind of fizzles out, right? And then you get it back again. That doesn't always happen, but it does happen enough. Then there's issues like, well, what strategies are people using? How are they getting this to happen? So people pay attention to things like, well, how focused are you on the outcome? Does that matter? People use strategies like calling in their guides and asking their guides for help, or staying relaxed in a meditative state, right? There's all these different strategies, visualizing, right? There's all these strategies that people might use. Does that make a difference, right? So if you've got a group of 100 people, they may be using all kinds of different strategies. And is one strategy better than another? Or does it matter, right? So we have these issues. And then we have the question of maybe it's only found in certain people. Maybe there's some individuals who are really good at this. And then, most of us are just kind of, not so good, or average at best. So again, you're going to lose some of that information when you average everything out into these big studies. So these are some possible reasons why the effects aren't more impressive. And we're going to run into a lot of this actually in the study that I did. But where I'm going is that kind of moving away, not moving away, but the proof-oriented research has already been done 1 million times. Like, is there an effect? The answer is yes, right? So we don't really need to do that anymore. We've got that data. So what I'm more interested in is, it's called process-oriented research. So what are these factors that might play a role in the PK effects? So are there physical factors, biological, psychological factors that might influence these effects? Now, specifically because of my interests, I was interested in the brain. Is there something about the brain or what the brain is doing or not doing that might influence this work? And there's some data out there that is definitely suggestive. So for instance, there was a study done all the way back in 1975 where what they did was they primed participants with either right brain stimuli. So first everybody did like a relaxation thing, and then they would have one group listen to material that was more right brain. It was more creative, artistic, poetry, that kind of stuff. And they had another group listening to left brain stuff. So philosophical treatises and, lectures on mathematics, shit like that, right? Like very left-brained, kind of analytic kinds of thinking. So they would listen to this lecture, and then they would try the micro-PK experiment. And guess what? The right brain people did better. The people that had the right brain priming. So that was suggestive that maybe there's something in the brain or how the brain is oriented that might be important. But the stuff that's even more interesting for me is there's a researcher named Friedman, and he published 2 different case studies where he was looking at healthy and also neurologic patients and their performance on PK tests. And in 2003, he reported on one patient that was extremely successful. So this idea that maybe some people are better than others, right, at this. Really, really good at this. And turns out this person had damage to their left frontal lobe. So it was like, that's interesting. Could that be related? Could there be a relationship here? And then in 2018, published another case of a person who was moderately successful, not as much as the first person, but they did a pretty good job. And they had dementia-related tissue loss in their frontal lobes as well. So Friedman kind of developed this hypothesis that maybe there's something about the frontal lobes that normally inhibits psi. And that if you turn off the frontal lobes, in particular the left frontal lobe, maybe that will help you. It's like kind of getting the brain out of the way, right? It's disinhibited so that these abilities can come through. So this was Friedman's kind of idea. And then last year he published this study, and this is really what got me going when I saw this. So this was published in Cortex, which is a well-respected journal. Again, I was like, wow, Cortex published this. Okay, cool. And, you can see the title, Enhanced Mind-Matter Interactions Following RTMS-Induced Frontal Lobe Inhibition. What does all that mean? So what he did was, instead of looking at neurologic patients, he took a bunch of healthy subjects and he used repetitive transcranial magnetic stimulation, which I'll talk about in just a second. But he used that to temporarily shut down the frontal lobes, right? So RTMS, everybody's probably seen it before, right? It's a usually it looks like a figure 8, kind of a wand, and they can aim it at different parts of the brain and send electromagnetic pulses to the brain. So, repetitive transcranial magnetic stimulation. So you're stimulating the brain with certain frequencies. And if you use particular frequencies, it can basically create what they call a temporary lesion. So it essentially shuts down that part of the brain, right? And so particularly they were using something called a continuous theta burst stimulation, which we know reduces the activity in the brain. So their idea was, okay, we got 108 healthy subjects. We're going to divide them into 3 groups. One group is going to get stimulation to the left frontal lobe. One's going to get it to the right. And then one's going to be a sham. So they think they're getting stimulation, but they're not, right? And let's see how they do. And so the task that they had, it was a random event generator. And the way it was set up was there was a screen that the people would look at. and there was a line down the middle with an arrow, either pointing to the right or pointing to the left. And so that right or left arrow was controlled by the number of zeros and ones that showed up in the background. And so they would ask them, move the arrow to the right, move the arrow to the left. You know, they would ask them to do both, and they'd randomize what order they had them do that, and collect all this data. So basically for each person, they did 500 trials for 4 different conditions. So remember, a trial is one of those instances of capturing the ones and zeros, okay? And so the 4 conditions, one was intention to move the arrow to the right. One condition was intention to move the arrow to the left. And then they did control conditions for both of them, where they said, okay, leave the room. So they took the participant out of the room, and they said, okay, computer, our intention is for it to go to the right. They hit the go button and everybody leaves the room. So they're just letting it run on its own. And then they would do it again for the left. So they've got 2,000 data points per participant. So it's quite a bit of data. So what they found when they analyzed the data was that the left stimulation, again, remember, shutting down the left hemisphere, the left frontal lobe temporarily, showed significantly larger effects compared to the sham group. However, this was only with the intention to move the arrow to the right, which is kind of interesting all by itself. So maybe there's some sort of cross-lateral thing happening in the brain, right? You shut down the right and it affects, you shut down the left, it affects the right more. So you can kind of see that on this data plot. So this very first bar here, this is the left transcranial magnetic stimulation, and this is the right intention. And so you can see, here's how they performed. This was the control for that condition. And here's the sham down here. So when you compare the right intention here with the sham here, there was a significant difference. But they only found this when they weighted the data. Now, the reason they did that is because when you do a RTMS session like that, the effects typically last about 20 to 30 minutes. So the idea was that maybe the further away you get from the session, it's having less of an effect. So they actually weighted the data to favor the earlier trials, the ones that were closer to the stimulation. And that's where they found this result. So there did seem to be support for their idea that something about the left hemisphere, the left frontal lobe, is inhibiting psi abilities. And if you get that offline, then you have more success. So I saw this and was pretty excited because, it was a well-done study. It's published in a good journal. And so my idea was, okay, can we kind of replicate that? Except instead of using this big, fancy, expensive equipment that you got to go to a hospital to access, could we do it with low power stimulation? So instead of using this, RTMS, this giant RTMS device, we basically used, it's the same kind of idea. It's still repetitive transcranial magnetic stim, but it's very, very, very low power, right? So super low power. And so this was kind of the setup that we used. This is stuff I've got in my office. People can go and buy it, right? It's consumer available. So what I did was in this study was I got 10 healthy participants. Again, it was kind of a pilot. And we used this low power stimulation. And what we did that was a little bit different from the other study was we had every participant come in 3 times. So in the other one, everybody was just assigned one condition, left stim, right stim, sham. I had everybody come in 3 times, so they got all 3 conditions. One time they'd get left stim, one time they'd get right stim, one time they'd get a placebo. So with the placebo, I put the things on their head. I just didn't have them plugged in all the way. So I still ran the program the exact same way. It looked the same, but they weren't plugged in, right? So the person didn't know which one was which. Everybody did 3 conditions. And so this is called a within subjects design, right? Because everybody's doing everything. Now, I can't do a continuous theta burst program the exact same way the other one did. So we used really low frequency, 3 to 5 hertz, in kind of a randomized fashion as a way to try to quiet down that brain region. And we've seen from some other research that we've done that generally does the trick, can kind of quiet down that brain region. So basically the way we set the study up was that people would come in and whatever their condition was, left, right, or in the middle, first thing we would do is run the stimulation for 10 minutes. They weren't doing any tasks. The idea there was to give the technology a chance to influence the brain. So we let it run for 10 minutes to try to get some sort of an influence. And then we kept running the session for another 10 minutes actively. So they got 10 minutes total of stimulation. But during that second 10 minutes, we started doing the random number generator tests. And so we would take them through 3 runs. And I'll show you what a run is in a minute. But a run is basically a set of trials. And so each run had 200 trials. So while they were getting active stimulation, they ended up doing 600 trials. Does that make sense? Okay. Then what we did was after the stimulation was done, right? The 20 minutes are over. There's no more stimulation. We had them do the random event generator 2 more times. So there's no active stim. It's kind of after the stimulation's over. So those are going to be blocks 4 and 5. So blocks 1 through 3 was with active stimulation. Blocks 4 and 5 was after the stimulation was over. So now we have 1,000 trials per person per session. So we actually ended up with quite a bit of data, right? Because that's 3,000 per person because they came in 3 times. And we had 10 people. So we had 30,000 trials to work with, to look at the data. Now, what I want to do before we get into the results is show you what I'm talking about with what the feedback looked like and what the REG looked like that they were using. So let me pull up a different screen here. So I'm going to just kind of walk you through this and explain what it was, because each session takes about 1 minute and 40 seconds. So it's pretty short. So here's what happens, right? Is in this case, we told everybody to make more ones. We didn't give them a choice. We didn't do, up, down, whatever. We said, everybody make more ones. And we would start it. And what's happening is in the background, it's generating, call it 1,000 data points per second. And then every half a second, it would average that and say, well, in the last half of a second, were there more ones or more zeros? And then that's what's going to show up on the screen. So here's what it would look like. This is what they're seeing while they're doing the task. So if in a half a second time point, there happen to be more ones, then the red ball goes to the top of the screen. And there's a little bit of a higher pitched tone. You might be able to hear it. I'm not sure. I don't know if you can hear it or not. If there happen to be more zeros in that last half a second, the red ball goes to the bottom of the screen and there's a lower pitch tone. Now, there's also this trend line going down the middle, and that's showing kind of the cumulative effect. So you see it starts right in the middle because that's 50%. 50% zeros, 50% ones. And so what we expect is that, it's going to go up and it's going to go down. It's going to move around. But we expect it to mostly kind of hug the middle, right? That would be essentially 50%. So you can see the number of trials up here, right? And if you remember what I said before, each one of these sessions has 200 trials. So essentially the person is sitting here focused on making more ones for 1 minute and 40 seconds, but they're also getting feedback. They're able to see something that's showing them what's actually happening in real time, right? So similar to the arrows, the right and left arrows that are moving around, just a little bit different. Okay, So we're getting there. 178. You guys are sending the line down. What's going on? You guys focus on zeros. Okay, so you see, so this is a fairly typical session. Now, in this case, you can see there's a downward trend, but we can look at the data and, which button do I push? There, that one. So we can see in this case, there was 107 zeros and 93 ones. So even though there was more zeros than ones, it actually wasn't even statistically significant, the difference, right? So you can see the p-value here. Now, the p-value's flipped the other way because I set it for looking for ones, right? So, but so, we can collect this data. So that would be one block. They've got the thing on their head. And then we do it again, right? We pause for a second and go, okay, do you have any comments, questions? How'd that go? Okay, fine, ready, let's do it again. So we do it 3 times, we take the stimulation off, and then we do it 2 more times, okay? So let's look at the results. Got to get back to the other screen. Okay, so our first question was, does pulsed electromagnetic frequency, the way we're using it, did it influence performance on the REG? So we looked at this a few different ways. So the first question we asked was, well, let's take the left and right stimulation. So basically all of the stimulation, anything that involves stimulation, we're going to lump it together. So whether it's left or right, those first 3 blocks, we're going to look at that and we're going to compare it to everything that was no stim, right? So left and right at the end when there was no stimulation, and then also the sham, the placebo. And when we examined that, the significance level was 0.049. So remember I said anything that's 0.05 or below is considered significant. So that was just under the edge there, right? It just made it. Now I got to point something out here. We ran a variety of statistics, and normally what you would do is when you run a bunch of statistics, you would control for that by making the criteria harder for what's considered significant if you run multiple comparisons. We didn't mess with that, right? Because this was sort of a pilot and we were exploring. So that being said, if I was writing this up as a research study, a lot of these statistics wouldn't hold up because we would have to make the criteria more stringent, right? Okay, so then we looked at it a different way. We said, well, what if we took the left and right blocks where there was stimulation and compared it just to the left and right blocks with no stimulation? So we took the sham out of it. And this one was actually even a little bit more significant. So 0.021. Okay, all right, interesting. Well, what if we just looked at the left? Let's just compare the left stimulation to the left with no stimulation. And here it gets even better. Here the p-value is 0.016. So it keeps going down. So far we're seeing some good suggestions that seem to support what we saw before with the other research, right? That there's something about inhibiting the left hemisphere, the left frontal lobe, that seems to have an effect. Then when we looked at the right side, it's like, well, let's look at the right. So when we compared the right stimulation to the right with no stim, it was not significant. So we only got the effects when we were looking at the left side in particular, or when we were kind of throwing everything into a big pile. So on the surface, this seemed to support kind of this other research, right? And the idea that maybe we can use simpler technology to get these effects. Maybe it doesn't have to be something quite as high-tech as, the crazy hospital devices. Now, as you're going to see in a minute, the results get way more confusing. As usual with any kind of research in this area, you usually end up with more questions than answers, which is kind of where this is going to end up. So the next kind of question, does left PEMF stimulation result in better performance than the other conditions? Now we kind of answered that, but we wanted to look at it a different way. And the answer was no. And here's the reason why. So you can see the results for the left stimulation. So they were actually averaging about 102. Remember, 100 is average. And you remember that big study that I showed that said, like 50.016 or something was the, so 102 is actually pretty substantial. That's quite a bit over 100. And here's the sham. They're way down here at like 99.5. But here's why it didn't show up as significant is because look at the right stimulation. The right stimulation did almost as good as the left. So when we ask the question, is left better? Well, the answer is like, well, not really, because the right was kind of right there next to it. Theoretically, it was a little bit better than the right, but not enough to be meaningful. So it's interesting because this is a little bit different than what Friedman found, because this kind of suggests that stimulation on either of the frontal lobes might make a difference. Now, we also had another weird finding, and actually, this finding was totally thanks to my statistician, because I wouldn't have even thought to look at this, but he ran a correlation between the left front stim number of hits and the right stim number of hits per participant. Now, this is a little bit confusing, but I'll try to explain it. So each one of these dots represents one of the participants, one of these little black dots. And so what you end up seeing is that, let's just pick on this one right here. So this side is the right frontal stimulation. So they averaged 105 when they were getting right frontal stimulation. Now down here is the left frontal stimulation. So when they received that, they only averaged 98. So this particular person did way better when they got right stimulation compared to the left. Now down here, it's the exact opposite. Look at this person. Left stimulation, they averaged, 107.5. But then on the right side, it was 97.5 or 98. So what you ended up seeing is that when you start to map this out, it's actually a very significant correlation between these two. And what it suggests is that for some reason, certain people do better with one side than the other. So some people do much better if you give them left stimulation. Some people do much better if you give them right stimulation. So again, it goes back to some of that stuff we talked about at the beginning, like why don't we get more significant effects? And it's like, well, maybe because there's a lot of different variables going on here. If some people do better with one thing than the other, and you throw them all into one pot, you're going to be missing something, if that makes sense. Now, interestingly, if you remember when I talked about this study by Andrews in 1975 with the left and right brain prompting, you remember? What he found was that people that were doing the left-sided prompt tended to score negatively. So meaning, in this case, if you asked them to get ones, they got more zeros. Whereas the people that were doing right thinking tended to score positively. So this is interesting, right? Because it suggests that maybe there's a different way of paying attention or a different way of engaging with the REG, whether it's left-brained or right-brained, whatever that might mean, that seems to maybe have an effect on which direction it goes. And so perhaps that's why we were seeing some of the results that we got. Some people did better with left, some people did better with right. Maybe it has something to do with their approach. This is what I mean, like things start to get messy, right? So to back up a step, it's like, well, why would influencing the frontal lobe, why would downshifting the frontal lobe have something to do with performance on this kind of a task? And the one thing that's been speculated is that, well, not even speculated, we know that one thing that the frontal lobe has to do with is self-awareness, both the left and the right. And there's been some different research suggesting that less self-awareness is better for different psi abilities. So I've got a couple of bullets there, right? So mental immersion leading to a loss of awareness of oneself and immediate surroundings. So that's kind of how we're describing this. Altered states of meditation, hypnosis. So all of these different conditions tend to show better psi effects. So perhaps partly why we're getting these effects with the frontal lobe is because we're reducing self-awareness. if you can shut down the frontal lobes a little bit, maybe you're paying less attention to yourself, which is usually a good thing, and then you get better effects. The other thing that comes up a lot is the role of attention and focus. And I've kind of already suggested this, but we know from other research that sustained attention seems to be important for certain side effects. You got to be able to pay attention to what you're doing, right? So that seems to be important. Now, what's interesting is that the right frontal lobe tends to have more of an impact on sustained attention than the left. And so that's why Friedman speculated that maybe that's why the left is better, is because you're reducing self-awareness, but you're not inhibiting focus or attention. So that was Friedman's hypothesis. Maybe that's why the left side is better. But we didn't find that in ours, right? Like the left and right seem to do semi-equal in terms of the impact. So to me, it goes back to this idea, maybe it depends on how you're paying attention or how you have to shift your attention. And there may be some evidence for this in some recent research conducted by Dean Radin. I already mentioned him once, the chief scientist at IONS. This hasn't even been published yet, but I heard him talking about it on a podcast. And they were doing, it was a different kind of a PK test, but it was a PK test. And what he did was he compared magicians, not stage magicians, right? Like, not watch me pull a rabbit out of my hat. Not that kind of magician, but people that practice high magic, with a CK at the end. So he compared them to meditators on this PK test. And the idea being is that magicians tend to have an external focus. The whole practice of magic is influencing something external with your attention. Whereas meditators tend to have an internal attention, right? So this was his idea. And he said, well, gee, I wonder what would happen. And guess what? The magicians did better. The magicians did statistically better than the meditators. So again, this kind of suggests that maybe there's something about the way we pay attention that becomes important. And of course, the right hemisphere is going to be involved in that. Now, we had some other weird stuff that we saw too, right? So we looked at, well, what happens when you take away the stimulation? So you remember, they got stimulation for 3 blocks, then we took it away and they did 2 more blocks. And so check this out. If you look at the yellow bar, so here's the left performance when they got the stimulation. So, you remember from before, they scored 102. That was their average. Look what happened when we took away the stimulation. All of a sudden now they're down to 98.5. That's a huge decrease. And look at the right side. It's similar, just not as dramatic. So they were up here to 101 point something and then dropped down to 99 point something. Similar thing. So let's just talk about that for just a second. So we got this consistent finding that people do better when they're getting the stimulation. And as soon as you take it away, their performance tanks. And so why might that be? I don't know this, but what I'm speculating is that maybe there's a rebound effect in the brain, right? You're actively shutting it down and going like, stop doing what you're doing. And then as soon as you take that away, the brain rebounds. It like wants to get back in control. And so if in fact that's what's happening, it would make some sense, right? That they would actually do considerably worse once you take the stimulation away. Now, the weirder part, look at the sham. Now, remember, the sham, they got the exact same process. The only difference was that there was no stimulation at all. But from a statistical perspective and trying to keep things clean, it's like, well, let's break it up the same way we broke up the other conditions. So the first 3 blocks were pretend stim in this case, and the last 2 blocks, there was no stim. So look at this. This is super weird. So the sham group, when they thought the stimulation was on, they scored about average, right? 99 point something. But look what happened when they thought the stimulation was off. It increased dramatically, and now it got way better than the other groups. And it's like, what in the world? Like what the heck is going on here? And honestly, I don't have a good explanation for that, except perhaps that there's some sort of a practice effect, right? So there's no stimulation at all. So perhaps by the time they got to the fourth and fifth block, they were starting to figure this out, right? They were starting to figure out like how to focus their attention, what kind of strategies seem to have an impact. And so they were getting better results. So that kind of makes some sense. And we talked before about the decline and recency effects, right? So that might fit with that. But then you could look at that and go like, well, wait a minute. Well, why wouldn't we see that with the other groups? And so the theory that I've got at the moment is that the stimulation and the post-stimulation kind of overrode that. So any kind of practice effects that you might have got was overridden by the fact that we took away the stimulation. And so that brain kicked back into gear. Now, I don't know that this is the truth. This is what I mean. It raises more questions, right? Because it's like, what in the world is going on here? It's super interesting, but it's also super weird. Welcome to my world. So I don't want to get too far down this rabbit hole because it starts getting a little bit, a lot. And we're starting to run out of time already, of course. But basically, this is just pointing out what we had already kind of argued about, is that certain people seem to improve over time, and some people seem to get worse over time. So again, we've got this weird effect where different people have different influences. So you can look at their sessions. This is the sessions they came in, first, second, and third session. And so like look at number 10, participant 10, they got the exact same average every time. But then you got people like subject 8. So they average 98 the first time, 100 the second time, 106 the third time, right? Or somebody like subject 5, 103 the first time, 103 the second time, 98 the third time. So you have these different effects where some people seem to do better over time, some people seem to get worse over time. So this gets into this idea of individual differences. And is it possible that this is another influence? And I would suggest probably so. So again, other researchers have talked about this. So like, remember that PEAR data. So they talked about a talented subpopulation. So what they found was that of the 91 participants, 2 of them achieved Z-scores of 5.6 and 3.42. Now, to put that in percentage terms, that means that they were better than 99.9999999% of the population, right, at this. So they were like rock stars, right, at doing this. The other 89 people averaged a Z-score of 0.82, which is kind of like, meh, it's more or less in the average range. So again, you've got these couple of people who are just like really good at this. And then Dobbins kind of talked about this as well and found that 15% of the participants were responsible for the findings, right? So he had some findings, but it's like, there's really only a handful of people that are making this up. And then again, Bosch did the same thing. He selected people specifically based on their previous performance and then compared them to people that just randomly picked. And again, look at these Z-scores. So if they were selected, their Z-scores were 6.87. Again, that's like 99.9999999, ridiculous number. Unselected Z-score, 1.84. That's still decent, but it's nowhere near this. So it does look like maybe there are specific individuals that are good at this. I'm going to skip this slide because of time, but it just makes the same point. The one thing I will bring up on this slide, there's a lot on here, but we looked at, these are subject numbers. So I want to just focus on this green block. And we said, well, how many subjects scored above 100 or below 100 in this particular condition? So if the stimulation was on, and it could be left or right, every single person scored above 100. Nobody scored below 100. So I thought that was interesting, right? Because again, it points again to the idea that there's something to this, right? That stimulation does seem to influence people's performance. Because if you look at every other condition, every other way we broke it down, there's always some people that scored below 100. Okay. Again, just wanted to point out some of the individual scoring patterns. So you saw what it looked like when we just ran it randomly. So sometimes you see stuff like this, right? So somebody really doing well. So really pushing this thing up to the ones. And then sometimes you see this stuff, right? Where even though this is from this testing. So we're asking them to focus on ones, but then this is what you get. You know, this really strong movement toward the zeros. So we found that 3 of the people scored consistently low. Didn't matter what we did, it tended to go toward zeros. And then 3 of the people scored consistently high, right? No matter what we did, it went up. And so again, other people have noted this, that some operators achieve PK results in only one direction, some in neither, some in both, and some showed inverted results. So this is what I mean. You start going down this rabbit hole, and it's like, this is a mess. This is like, how do we make sense out of this, right? There's like a lot going on here. The one last little thing I'll bring up here is that, and I think this is important, because remember trying to understand those sham results, and it's like, what the heck was going on there? Why were people doing better in certain circumstances during the sham? And we actually found a correlation, or not a correlation, but statistical significance related to a couple of personality or psychological factors. So with the sham conditions, people that scored higher in openness to new experiences and people that scored higher in psychological flexibility both did better in the sham condition. So again, if you take away the stimulation, then maybe these psychological variables become more relevant, right? I think the stimulation overrides some of this stuff. But then when you take that away, it's like, well, then what is influencing it? And it may be some of these kind of factors. Okay, I knew I had too much stuff. I just want to show you, I'm going to skip a couple of things here. But the other thing we did was we monitored people's heart rates during the sessions. And unfortunately, a lot of the data got corrupted and we weren't able to analyze it the way we wanted to. But what we did do was pull out some of the clean data just to look at just from a case study perspective. And so on these couple of slides I'm going to show you, the blue line is actually the REG performance, right? The random number generator going up and down. The red line is the heart rate. And of course, the heart rate is going to go up and down because that's what it does. So these little waves. But what's interesting is in many cases, we saw this trend where the heart rate seemed to follow the RNG. So like in this case, they're both kind of going up and then they both start coming down. Here's another one. It's kind of flatlined. The RNG starts going up. This one starts trending upward. The heart rate does. This is probably my favorite just because it's like you can just lay them on top of each other. So again, this pattern of the heart rate seeming to mirror, or maybe that's not it at all, right? Maybe there's some sort of an influence, but the heart rate seems to be mirroring the direction of the RNG. And so I suspect that this has something to do with effort. How much effort are you putting in? So there's been this idea that maybe there's sort of an effortless effort is what's important. Don't try too hard. Stay relaxed. But this has actually produced mixed results. Sometimes that seems to work, sometimes it doesn't. Big shock. That seems to be the theme here, right? And so what's interesting is that it may be that as somebody is more aroused, they actually do better. You may have to increase arousal, get your heart rate up a little bit, and people do better. And it's interesting because I remember talking to a few people after they did their trials and asked them what they were doing. And one person was talking about like they were holding their breath, right? And that seemed to, in their perspective, seem to do better. And of course, if you hold your breath, your heart rate's going to go up, right? So it's interesting that there at least was some subjective sense that maybe there's something going on there. So the conclusions. Looks like PEMF stimulation does seem to have an effect on micro-PK abilities. The left and right stim didn't seem to make a difference, really. The left might have been slightly better, but the right also had a strong effect. There seems to be this weird preference. Some people do better with the left, some people do better with the right. After the stimulation, there was this significant rebound where all of a sudden things went the opposite direction. So suggesting maybe some sort of like a brain rebound. In the absence of stimulation, so like the sham condition, mental state of the person may be relevant, may be important. So the things like openness to new experience, psychological flexibility. Some people seem to be just really good at this, that, there's some individual differences, could have something to do with focus, could have something to do with arousal. So when I was talking to my collaborator on this, David Jaffe, who is the one that created the software, this is his quote at the end. He said, "How do you control for confounding variables when you don't even know what they are?" And I was like, yeah, it's like, this is our problem, dude. So there's obviously some things we want to do in the future. So I want to do a better job at picking the frequency for inhibiting the brain. We need to have some better control conditions. Need to look at things like how much focus and stress and effort were they engaging in during the activity? What strategies were they using? Right? Was it the visualization, or was it asking your guides for help, or what? Trying to establish if there's left and right hemisphere dominance. We may be able to tell that by how they're breathing out of their nose. So there may be some ways to establish that. And then, of course, looking at brain waves would be really interesting to do as well. So the trick is, I just need to find a gazillion-dollar grant, and then we can do all that. Actually, the whole idea with this was going to be a setup to apply for a grant, which I did, but unfortunately I didn't get it. So wait till the next round and try again. Okay, so I know I'm over barely, and I kind of blasted through a ton of this. I'm okay with hanging out for a minute if people have questions or want to bring up any ideas or thoughts or comments, anything at all. It was a lot.
Hi. Oh, am I talking over someone? I'm so sorry.
Go ahead.
Sorry. Tarrant, I texted you because for some reason I'm having some sort of issue with being able to put it in the chat, but you know me, I asked a slew of questions, so feel free to ignore some or divulge others, up to you.
Oh, in text, you put them in text. Okay, all right. Yeah, I'll catch up with you later. Oh, you want me to get them now?
But I'm saying the group could benefit potentially.
Gotcha. Okay. See, this is the danger of giving Mercedes your cell phone number. Holy crap. The placebo studies with stim in your office, does the stim have a sensation? Meaning, does the subject feel anything when they're stimulated? No, but because this is such low power, you don't feel anything with the stimulation either. And so that was another thing I would ask people, like, hey, which one do you think was the placebo? And almost nobody got it right. And so, out of 10 people, if a couple of them got it right, it's like, well, that's just chance, right? That doesn't, but most people can't feel the difference because it's such low power. The amount of power coming out of this thing is like the amount of power that comes out of your earbuds that you're wearing in your ears. It's very low power. So the idea is that we don't have to necessarily hit the brain with a sledgehammer to get it to move. The brain responds to low energy. You don't have to whack it. But that's why we had to stimulate it longer too, right? Because if you use the big RTMS device, you actually can't stimulate the brain very long because you'll overheat it. It's like really intense, right? So like it's got to be short. But with the low power stuff, you can do it for a long time, right? But you have to get an effect. I'll look at this other one, but if anybody else has a question while I'm scanning through Mercedes' questions.
Speaking of low power devices, could people play around with this on their own with a neorhythm?
You could. The only trick, so the neorhythm, if you're not familiar, it's kind of like a headband shape, and it's a commercial device. You can control it with your phone. It's a Bluetooth thing, and so you can. In fact, actually, that's an interesting idea, because one of the things that I've always struggled with like the neorhythm, it's got four. It's not sensors, four stimulation pods. I don't know what the right term is. I can't think of it. And so two of them are in the front of the headband and two are on the side. You can move the headband however you want on your head. When in the controls, it doesn't let you distinguish right from left, which is why I've always struggled with it, because if I want to isolate the left, I can't really. However, you can isolate the front from the sides. So if you were interested in just doing the whole front, you could definitely do that. Somebody asked a question in the chat. Have you mapped Carolyn Corey during PK stuff? I have. I have mapped Caroline Corey. So if you don't know her, she's done a few different documentaries looking at this kind of stuff. Superhuman was the one that really first caught my attention. I think it's on Amazon and various things like that. Really interesting, really well done, looking at some fantastic abilities that certain people have. And so I connected with Caroline and I mapped her brain while she was doing a PK experiment. And I actually talk about that a little bit in my book. So those of you that have the book, Becoming Psychic, she's in there. And we talk about her brain results when she was doing a PK test.
Jeff, I don't even know if I can formulate a question because there's a lot running around in my head now. But the idea of, and I'm not even sure if I'm accurate, taking the frontal lobes offline, seeming to be able to access things and connecting that to energy healing or frequency healing. So I don't have a question, but can you comment on that?
Sure. So it's interesting because, I've done a fair amount of brain mapping with different things: energy healing, mediumship, psychic stuff, telepathy, right? I've looked at a lot of different things, channeling. And what's interesting is that in a lot of those things, the frontal lobes are involved. It's usually the right frontal lobe, which is interesting in relation to what we've been talking about. And so, but what's funny is that sometimes people will deactivate the right frontal lobe, and sometimes they kick it into high gear. And so again, to me, it's suggestive of the same thing that we were just talking about, that maybe different people have to shift their focus in different ways. Maybe some people have to relax their attention, and maybe some people have to engage their attention, more specifically, to get into whatever that state is. And so I think this is a problem that we're running into with this kind of work, is that there's a lot of individual differences. Everybody's not the same. And so if we try to apply the same idea to every single person, we're not going to get anything. And actually, to me, that actually makes more sense than imagining that everybody's doing the exact same thing and their brain is doing the exact same thing. That actually makes less sense to me. But the frontal lobe is often involved. The other part that's often involved is the right parietal lobe, which also goes offline. And so it does seem like the brain, we know the brain has a lot of what the brain does is inhibitory. It's stopping things. It's filtering information. And so it seems like there's certain areas of the brain that if we can get them to relax that inhibition, then it allows more abilities. So the right parietal lobe, the frontal lobes in particular, seem to do that a lot. So I think there's something to that. Anything else? I got a couple minutes. And then I got to hop on another thing. Go ahead.
I have one more question. So I was wondering, like, have you also calculated or maybe found out the IQ of the people? Because for some people it was like always high, and for some people it was always low, as you have shown in the results. So what, like, did you calculate IQ or maybe EQ and then try to correlate with the patients and the performance?
Yeah, it's an interesting idea. No, I didn't do that, and again, this was sort of a pilot, and I already asked a lot of these people. They had to come into my office 3 different times, right, and do this. It's an interesting question. So far, the best sense that I have of why some people consistently went low or high seems to be related to that left brain, right brain thing. And I'm basing that off of that previous research. And so, I think I think it's an important question for us to figure out. So maybe the next round of research, could start to get at more of that. And of course, I don't want to give everybody a Wechsler test or something, right, to measure IQ, but maybe there's some kind of simple cognitive battery that's computerized that I could give people that wouldn't, would only take 15 minutes or something, and at least give us some metrics.
I was wondering about one more thing.
Yeah.
So is there anything called stress coefficient or maybe an anxiety coefficient? Like how much a person is anxious or stressed at that particular amount of time? I'm not sure whether it already exists. And if we have that particular metrics, then can we also relate that with the maybe performance of the people? Because for some people, they have to be like more attentive, then it works. And for other people, they have to be less attentive for it to work. So I was wondering, is there anything like that?
Yeah, and again, I didn't do that in this test, but it would have been a brilliant thing to add, and I wished I would have, because we do see that if people are feeling stressed or anxious, they tend to perform worse on these kinds of tests. There needs to be a certain level of some level of relaxation, or at least not tension. And what's interesting is, because of the way the study was set up, everybody got the same treatment, meaning everybody was watching the feedback on the screen as it was happening. And what I've observed from doing this kind of work with a lot of different people, some people like the feedback, and some people, it makes them anxious. So, they're watching what's happening, and all of a sudden it starts going the wrong direction. And then they get in their heads, right? And it's like, oh shit, right? It's going the wrong direction. How do I, and so, even that, like how we're providing the feedback is an important variable for certain individuals. And again, that makes it tricky from a research perspective, because from research, you want everybody to get the same thing and to do the same thing and have the same, process. But I don't think that that's the way it works for everybody.
Yep, thanks.
Yeah. All right. So Mercedes, I didn't get to all your questions, but I will, I'll shoot you a message later. And if anybody else has any questions or, needs to get in touch with me, my email is, you can reach me at info@neuromeditationinstitute.com. And I'll try to help you and get back to you in whatever way possible. Thanks for being here, and hope to see you guys all in the future.